So now let us continue our discussion on what is kinetics and kinematics in dynamics. So therefore, can you tell me the Newton's second law? Krishna.
Second law.
Yeah.
So the summation of all the forces acting on a body is equal to the rate of change of momentum.
So it is equal to the rate of change of momentum in that particular direction in which you are seeking the sum of all the forces. Do you agree with me?
Yes, sir.
And if the mass remains fairly constant throughout the observation, then we can take mass outside the derivative and we can call it as m into ax. Okay.
Yes, sir.
And now we are going to perform a thought experiment. And just give me a minute. Yes. So we are going to perform a thought experiment. And we are going to ask certain questions about the motion under study pertaining to this experiment. Are you with me? Let
Yes.
us say this is the object placed on tabletop. Object placed on tabletop. And we are applying force F here such that there is no frictional resistance. Tabletop is frictionless. Are you with me?
Yes, sir.
Yeah. So what is going to means what is going to be the effect if I apply this force on this box? What is going to be the effect? Tell me.
Sir, the box will move forward.
Yeah. So there is going to be translation of the block in the direction of the force. Do you agree with me?
Yes, sir.
So what has caused the motion? Force has caused the motion.
Hello,
Yes.
sir.
Yes. Who is this?
Sir, I got the unmute request now.
Who is this?
Sir, Rishabh Raut.
Rishabh Raut. Okay. Rishabh, in such case, but did you listen to when I asked you to unmute? Did you listen to me that
Yes,
time?
sir, I listened, but the chat box wasn't opening as well. My entire WebEx was glitching, and I got the request now.
Okay, no problem. So henceforth, if such thing happens, just put the message on WhatsApp at that time.
Sir, I have.
Okay, great. So I would anyway consider that way. Sorry, you are Rishabh, right?
Yes, sir.
So I'm aware that there are many internet issues and there are going to be such problems around. But at some point of time, I have to ensure that the class is participating. So some measures are required. Genuine problems will be always handled in a different way. So if any such thing happens, you can immediately drop me the message on WhatsApp if no chat and no mic is working here. All right. But in general, I am going to call random names and you have to participate. Then only this exercise makes sense. Chalo, Krishna, are you there?
Yes. Yes, sir.
Yes. So this is going to cause the motion along the frictionless surface, right?
Yes, sir.
What caused the motion? If that is the question that I asked, if that is the question that I am going to ask, then what is the answer? This force has caused the motion. Are you with me?
Yes, sir.
To be more precise, I have to say that unbalanced force has caused the motion. If I do algebraic sum of all the forces acting on this body in this x direction, then there is an unbalanced force F. This is the force which is not countered by equal and opposite force. Do you agree with me?
Yes, sir.
That has caused the motion. So what is the cause of motion? Unbalanced force.
Unbalanced force.
So I am going to list down certain questions that I have asked into either in kinetics or in kinematics. So looking at its placement, you are going to later define what is kinetics and what is kinematics. Okay.
Okay, sir.
A funny exercise, but that's what we should do. We should not believe on the textbook definitions and go ahead. We should ask why, what is the reason, what is the logic for defining it in this way. So there are various questions that we are going to ask. I am going to categorize them either under kinetics or under kinematics. So the first question that I asked is, what is the cause of motion? Do you agree with me?
Yes, sir.
What is the cause of motion? cause of motion. This question I have listed under what? Bolo? I have listed it under kinetics. Are you with me?
Yes, sir.
The next question. An observer is observing this block to move. Dekho, the observer is observing this block while it moves. Are you with me?
Yes, sir.
And the observer is not merely a spectator. He or she is also measuring the velocity, displacement, and acceleration of the block by some measures. Are you with me?
Yes, sir.
And the observer observes that during first 5 seconds t equal to 0, that is the start of observation, to t equal to 5 seconds. Are you with me?
Yes, sir.
The block possessed uniform acceleration in x direction, which is equal to 2 meter per second. Are you with me?
Yes, sir.
So observer observed two things here. Point number one, the block is moving along a straight line. Point number two, acceleration of the block while it moves during interval t equal to 0 to t equal to 5 seconds, it possessed uniform acceleration which is equal to 2 meter per second. Are you with me?
Yes, sir.
And now, if I were asked to calculate the velocity at the end of this time interval, if the velocity at time t equal to 0 is 0. Are you with me?
Yes, sir.
And I am asked what is the velocity at t equal to 5 seconds. Are you with me?
Yes, sir.
Now this question I am going to categorize under kinematics. So given initial velocity and observation on acceleration, find or what will be the final velocity at the end of 5 seconds. Here it may be at the end of 10 seconds, 20 seconds, whatnot. Are you with me?
Yes, sir.
Final velocity. This question I have listed under kinematics. Happy? Are you
Yes,
with me?
sir. Yes,
Okay.
sir.
Let me ask one more question. The question that I'm going to ask is, let us say this block is acted upon by the force of 100 Newton. Are you with me?
Yes, sir.
100 Newton, and the mass of the block is 20 kg. The surface is frictionless. What is the acceleration in x direction or in the direction of the force that this block possesses? Is the question that I have asked. Are you with me?
Yes, sir.
The second question I ask, if I double the mass for the same force, what happens to the acceleration? Are you with me?
Yes, sir.
So how are you going to calculate it? You are going to use Newton's second law. 100 is equal to 20 into x. So you will get x. If you double it, it will be 40 into x. You will get the value of x. So second question. For a given force and mass, compute acceleration. Are you with me?
Yes, sir.
Computer. I have listed this question under kinetics. Also, there is a sub question to this. What happens if I halve the mass and keep the force constant? I cannot write everything here, but you have to understand all such sorts of questions are listed under kinetics. Are you with me?
Yes, sir.
Next question that I asked is, given the initial displacement and initial velocity, can you tell me the final position of the object, knowing the acceleration is constant? Are you with me?
Yes, sir.
This is listed under kinematics. तो क्या अब आप बता सकते हो मुझे कि how should we define kinetics and kinematics? कैसे define किया जा सकता है?
Sir, in kinematics
Yes, go ahead.
we basically find the value of the final velocity or displacement, like what will be the final position.
Hmm.
And in kinetics, uh,
Hmm. Okay, so let me define it for you now. I think I have clearly stated what are the questions to be asked in which branch, kinetics and kinematics. So let us now define what is kinematics and kinetics. So kinematics is the branch of dynamics which deals with analyzing the motion parameters like displacement, velocity and acceleration, but it will not look for the cause of the motion, or it will not look for the effect of changing the mass on these parameters. Are you with me?
yes, sir.
We will simply look at acceleration, velocity and displacement. These parameters, these are motion parameters. So we are only going to observe the geometry of the motion in some sense. Do you agree with me?
Yes, sir.
So this is called as kinematics. For example, a traffic police standing on a road and measuring the velocity of a speeding vehicle comes under kinematics. Are you with me?
Yes, sir.
The police is not bothered about what engine does that vehicle have, what is the force exerted by engine on the tires, and why that vehicle is moving fast. He has no business about of thinking of that. Do you agree with me? He has to simply
Yes, sir.
measure the speed, whether it exceeds a particular limit or not. So whenever we are talking about observing and motion and predicting its geometrical parameters like acceleration, velocity and displacement based on our observations, and we totally disregard the cause of motion or the parameters that affect the motion, for example mass and force, then in such cases we call that branch as kinematics, where we deal with only geometry without looking at the cause. Are you with me?
Yes, sir.
For example, moon completes one round around the earth in so many days. This observation, we are not worried about what caused the moon to move around the earth. Do you agree with me?
So,
We don't talk about gravitational pull, we don't talk about orbitals, nothing. The cause is not required, but we simply state the observation that moon completes one round around the earth in so many days. Are you with me?
yes,
So
sir.
we are observing merely the geometry or merely the motion parameter. In such cases, we call that problem as kinematics. Are you with me?
Yes, sir.
Now, what is kinetics? Kinetics, on the other hand, deals with the cause of the motion. What caused this object to move? A force of 100 Newton. What if I change its mass to half? What is going to happen to the acceleration, velocity and displacement after time t? Are you with me? All
Yes,
these
sir.
questions which are the cause of motion, interrelationship between acceleration, mass and force, all such type of questions, they come under kinetics. Happy?
Yes.
So if I say tomorrow if the gravitational constant of the earth gets doubled, then in how many days does the moon complete one round around the earth? This question now will deal with kinetics. Are you with me? Because you will have to study the cause of motion, which is gravitational force.
Yes, sir.
Not only gravitational force, but you will have to study the effect of all forces acting on moon. Do you agree with me?
Yes, sir.
So therefore, kinetics is the branch where we deal with the causes of the motion, where kinematics is the branch where we deal with only motion parameters such as position, velocity and acceleration. Happy?
Yes, sir.
Okay. तो एक ट्रिक ध्यान में रखो. The branch that involves the study of force and mass m, उसके spelling में m नहीं है, kinetics. Are you with me? Whereas the branch where we do not look for forces and mass, m, उसके spelling में m है. Are you with me?
Yes, sir.
So this is the simple trick to remember, but kinematics is the branch where we disregard the cause of motion, we disregard the relationship between force, mass and acceleration. We simply observe the geometry of the motion. Happy?
Yes, sir.
Okay. So being said that, to start with, we are going to deal with kinematics. We will begin with kinematics. So in dynamics, right now we are studying kinematics. Are you with me?
Yes, sir.
So we are going to concern only about the motion parameters, and we are not bothered about what has caused the motion. Now, let us define three fundamental quantities. First quantity is position. So you must have heard the word position, velocity and acceleration during your study of rectilinear and curvilinear motions during 11th and 12th standard. Have you heard these words, Krishna?
Yes, sir. Yes, sir.
Okay. So can you now tell me, what do we mean by position of an object?
So position is basically the
Yes.
position, sir.
So I will try and help you in this regard. So this is X, Y, and this is Z. Are you with me?
Yes, sir.
These are the three axes. Now let us say at time t equal to 0, the object was occupying this point in this space. Are you with me? And I am now going to assume that the object is represented by a point. Particle idealization. Are you with me?
Yes, sir.
In statics and dynamics, we often make the particle idealization. In statics, we do particle idealization when we are not interested in shape and size of the body. In dynamics, we do particle idealization when there are certain sets of conditions that are satisfied. We will see that later. But right now, let us say at time t equal to 0, the object has occupied this position in the space. Are you with me?
Yes, sir.
And at time t equal to 5 seconds, it has assumed or it has acquired this position. Are you with me?
Yes, sir.
And during this time interval, the path that is followed is this one. Are you with me?
Yes, sir.
This is the path followed by the object from t equal to 0 to t equal to 5 seconds. This is the direction of motion. Happy? Are you with me? Okay. Now, so as I plot this path, you have to understand that each point on this path has been realized at different instants of time. Though I have plotted it as a graph, all the positions on this graph have been achieved by the object during different intervals of time. Do you agree with me?
Yes, sir.
So therefore here, the time which is not seen on XYZ axis is called as implicit parameter. क्या बोलेंगे इसको?
Implicit
Implicit
parameter.
parameter. So whenever I draw a path in the space followed by the object, each position on that path is achieved by the object at different instants of time. So as the particle moves from one point to other point in the space, the time is evolving implicitly. It will not be seen on the graph, but it is evolving implicitly. Are you with me?
Yes, sir.
So time is implicit parameter. Unless I say this is the position corresponding to t equal to 0 and this is the position corresponding to t equal to 5 seconds, I will not be able to grasp what is happening in time. Do you agree with me? Whether this particle has covered the distance in 5 seconds, 10 seconds, 12 seconds, 1 hour, 2 days, this all will be unknown unless I specify it. Are you with me?
Yes.
Okay. Therefore, time is implicitly evolving along the path. Now, next question. If I ask you at time t equal to 0 seconds, how do you recognize the point in space where the particle was? So you will have to first define an origin, and then you may choose a type of coordinate system. Here we have chosen a Cartesian coordinate system. So it has three axes, x, y, z. It's not like x is vertical, x is horizontal and y is vertical. If you go in space, there is no notion of verticality and horizontality. Are you with me?
Yes, sir.
So x, y, z are mutually orthogonal. That's the only thing that they have to follow. X is perpendicular to y and z, y is perpendicular to z and x, z is perpendicular to y and x. Passing through O. This is our origin and reference coordinate system. Are you with me?
Yes, sir.
Now, how do we define position of a particle at the start of observation, which corresponds to t equal to 0 seconds? So you have to join this origin with this point, and this vector is called as position vector r bar at t equal to 0 seconds. So this is the position by definition of a particle. Do you agree with me?
Yes, sir.
So first observation, position of a particle in a space at given instance of a time is a vector quantity, not scalar quantity. Do you agree with me?
So,
Now tell me, what is the position of the particle at t equal to 5 seconds? Bolo?
sir, it will be zero. Origins to that. Yeah.
So this is r bar at t equal to 5 seconds. This is the position at t equal to 5 seconds. Do you agree with me?
So,
Just give me a minute. Let me take this down. Very carefully listen to what I am trying to say. Bring all your conscious in your ears. This is very important concept. Now, if I ask you, what is the change in position that the object has displayed during 0 to 5 seconds? तो मुझे क्या करना पड़ेगा? So let me now name this position vectors. I am going to call it as R0 bar. Are you with me? And I'm
yes,
going to call this as R5 bar. So what is R5 bar? R5 bar is the position of particle at t equal to 5 seconds. And R0 corresponds to position vector of a particle when t equal to 0 seconds. Do you agree with me?
so,
And now what is the change in position? Change in position is nothing but this vector, if you agree with me.
yes, sir.
This is the change in position. Are you with me?
Yes, sir.
So how do I represent this vector? I represent it as delta r bar from 0 to 5 seconds. Do you agree with me?
Yes, sir.
It is the change in position vector as the particle move from position at t equal to 0 to t equal to 5 seconds. Agreed?
Yes, sir.
Now, second question. What is the relationship between R0, R5 and R delta R0 to 5? तो देखो ये ट्रायंगल लॉ दिख रहा है कि नहीं? R0 bar, देखो R0 bar plus this delta R bar. Do you agree with me?
Yes, sir.
By triangle rule, this addition has to be equal to R5 bar. Do you agree with me?
Yes.
ट्रायंगल रूल हम कैसे करते हैं? फर्स्ट वेक्टर फ्रॉम टेल टू टिप, सेकंड वेक्टर फ्रॉम टेल टू टिप, एंड इन दोनों का एडिशन विल बी द वेक्टर जॉइनिंग द टेल ऑफ फर्स्ट वेक्टर एंड टिप ऑफ अदर वेक्टर बट इन रिवर्स ऑर्डर.
Yes, sir.
यही है ना ट्रायंगल लॉ? डू यू एग्री विथ मी?
Yes, sir.
So that's what I have written. The first vector from tip to tail fashion, R0 bar. Second vector from tip to tail fashion, that is delta R bar. And addition of these two vectors is going to be the third vector, but in reverse sense. So it is R5 bar. Do you agree with me?
Yes, sir.
Okay. So in other words, how do I write delta R bar? Tell me.
R5 bar minus R0 bar.
Great. So delta R bar, as our intuition would have said, it is equal to R5 bar. That is the position vector corresponding to the position of particle at t equal to 5 seconds minus R0 bar. That is the position vector corresponding to the position of the object at t equal to 0 seconds. Happy?
Yes.
So this is called as change in position from time 0 to 5 seconds. Now if I replace this 5 by any arbitrary time t, what is the relation I am going to get? Delta R bar during 0 to t is equal to RT bar minus R0 bar. Do you agree with me?
Yes, sir.
Okay. Now tell me, what is the distance traveled by this particle during this time? How much is the distance traveled?
Sir, distance is that.
This entire distance?
Yes, sir. That curve.
This is the distance traveled during 5 seconds. Do you agree with me?
Yes.
Is it same as magnitude of delta r bar? No. Delta
No,
r
sir.
bar's magnitude is only this much.
Yes.
Do you agree with me?
Yes.
So delta r bar's magnitude give you the shortest distance, straight line distance between the position at t equal to 0 second and t equal to 5 second. But it does not give you the total distance traveled by the object. Do you agree with me?
Yes, sir.
So we have to be very careful while defining the position. Position is not by any means the distance traveled by the particle. Only under certain circumstances the position and distance traveled will be same. Changing position and distance traveled will be same. Are you with me?
Yes, sir.
So summary point number 1, you have to understand change in position from t equal to 0 seconds to t equal to 5 seconds is not same as the distance traveled by the particle during time t equal to 0 second to t equal to 5 seconds. Agreed?
Yes, sir.
Okay. So if I am very clear, now we define unambiguously what is a position of a particle, and we have to understand that it is a vector quantity. Change in position is what we are interested in. Are you with me?
Yes, sir.
Because if you change the origin, R0 bar and R5 bar, their expressions are going to change. Do you agree with me?
Yes, sir.
But is delta R bar going to change? No.
No, sir.
For example, if I shift the origin somewhere here, what is R0 bar? This vector. What is R5 bar? This vector. But has delta R bar changed?
No.
So second point of observation. If you change the reference coordinate system, if you change the origin, delta R bar, change in position vector during 0 to 5 seconds does not change. What changes is position vectors at t equal to 0 and t equal to 5 seconds. Are you with me?
Yes, sir.
Okay. So therefore, we are not interested in this temporary changing quantities. We are interested in the quantity that remains unaltered under coordinate transformation or under shift of origin. Are you with me?
Yes, sir.
And which is the quantity that remains unaltered? Delta R bar. So most often while observing the motion, we will be interested in change in position rather than the position itself. Are you with me?
Yes, sir.
Okay. There are some instances where we will also have to deal with the position, but I am making a crude statement. 90% cases we will be interested in change in position during a particular time duration. Are you with me?
Yes, sir.
Okay. So now, how do you define velocity? Tell me.
So velocity is the change in position per unit time.
Yes. So if I express velocity as dv bar by dt, it won't be wrong. Do you agree with me?
So dr.
dr bar by dt. I'm sorry. dr bar by dt. Do you agree with me?
Yes, sir.
This is the velocity vector. Are you with me? But now we are going to define two types of velocities. कौन से velocities है? One is called as average velocity and other is called as instantaneous velocity. Are you with me?
Yes, sir.
So let us now define what is average velocity. So average velocity v bar average is defined over time interval t equal to 0 to t equal to t. And how do we define it? We define it as average velocity during time interval t2 to t1. t1 to t2. I'm sorry. t1 to t2. t2 is greater than t1. Are you with me?
Yes, sir.
So average velocity during time interval t1 to t2 is position vector at time t2 minus position vector at time t1. Do you agree with me? Divided
Yes.
by delta t. Delta t is nothing but t2 minus t1. Happy?
Yes.
This is how we define the average velocity. Are you with me?
Yes, sir.
But it may so happen that during this time interval t2 to t1, the velocity may not remain constant. Though this change in position is correct, But during all time intervals, during to T1 to T2, the object may not have had the same v. Do you agree with me?
Yes, sir.
So then we need to define something called as instantaneous velocity. So how do we define instantaneous velocity? So let me define it. 1 minute. So I define instantaneous velocity as v instantaneous, and I'm going to call that simply as v bar, as limit as t2 minus t1, or that is delta t. Do you agree with me?
Yes, sir.
Tends to 0 of r t2 bar minus r t1 bar. Are you with me?
Yes,
T2
sir.
minus T1. Happy?
Yes, sir.
This is instantaneous velocity at time t, at time t1. Why at time t1? Because t2 minus t1, delta t is tending to 0. So as if t2 is t1 itself. Are you with me?
Yes, sir.
So it is the instantaneous velocity at time t1 is defined in this fashion. Are you with me?
Yes, sir.
Now how does it look graphically? So let me show the graph as well, so that you will better understand this. Okay. Chalo. So let us say this is z-axis, this is x-axis positive, and this is y-axis. This is the origin. And at time t1, the object was occupying this position. At time t2, the object was occupying this position. Do you agree with me?
Yes,
This
sir.
is t equal to t1, and this is t equal to t2. Time is the implicit parameter. Are you with me?
Yes, sir.
Now, oh no, we should not have drawn this graph. Let me draw the graph of, no, that's correct, right? Now, चलो. So what is the average velocity from t1 to t2? क्या करना पड़ेगा मुझे बोलो? rt2 bar minus rt1 bar. What is rt1 bar? This is rt1 bar. Do you agree with me?
Yes, sir.
What is rt2 bar? This is rt2 bar. Happy?
Yes, sir.
So what is this? Is delta r bar. Do you agree with me?
Yes, sir.
And if I divide it by t2 minus t1, which is a scalar quantity, are you with me?
Yes, sir.
So I am going to get a vector quantity, but it will be directed along this line itself. Do you agree with me?
Yes, sir.
So it is going to be directed along this line itself. Why? Because simply I am going to divide this delta r bar by t2 minus t1. And that I am going to specify as average velocity during time v bar during time t1 to t2. Do you agree with me?
Yes, sir.
t1 to t2. Now let us look at the instantaneous velocity at t1. So for instantaneous velocity at t1, मुझे क्या करना पड़ेगा? This itself is t1 bar. Do you agree with me?
Yes, sir.
But now I have to choose t2 very close to this point. Do you agree with me?
Yes, sir.
So this becomes t2 bar. And then in that case, if I join these 2 points, the change in r bar is going to be along a tangent. Do you agree with me?
Yes, sir.
And that is v bar instantaneous at time t1. So are their directions different? Do you agree with me? V bar
Yes,
has different direction than v bar at t1. Happy?
Yes.
So instantaneous velocity is always tangential to the path, is the observation that I am making. Do you agree with me?
Yes, sir.
So note, instantaneous velocity of the object is always tangential to the path, whereas the average velocity during time t1 to t2 will be directed along the delta r bar from t1 to t2. Do you agree with me?
Yes, sir.
And these two directions need not be same. Similarly, these two magnitudes of velocities need not be same. Are you with me?
Yes, sir.
हाँ. So दो चीजें हमने नोट की है यहाँ पे. One is average velocity and another is instantaneous velocity. Mind you, both are vector quantities. Average velocity is also a vector quantity. Instantaneous velocity is also a vector quantity. Happy?
Yes, sir.
But what we have to understand is instantaneous velocity and average velocity have different directions and magnitudes. Agreed?
Yes, sir.
And second point, instantaneous velocity of a particle is always directed along the tangent drawn to the path at given instant of time. Happy?
Yes, sir.
Okay. So देखो ये दो observations हमने किए हैं. Now we will move ahead with velocity, with acceleration. So how do we define acceleration? Tell me.
Acceleration is the rate of change of velocity.
Yes. So will it be a vector quantity or will it be a scalar quantity?
So vector quantity.
Yes. So vector quantity, तो मैं define करता हूँ. How do we define acceleration? A bar is equal to rate of change of velocity. Again, I will have two notions of acceleration. One is average acceleration. Do you agree with me?
Yes, sir.
So what is average acceleration? It is acceleration at time t equal to t2 bar minus, sorry, velocity at time t2, velocity at time t2 bar minus velocity at time t1. Do you agree with me?
Yes, sir.
Divided by t2 minus t1. t2 minus t1. This is the average acceleration during time interval t1 to t2. I hope you have understood this. Are you with
Yes,
me?
sir.
And now let us write down instantaneous acceleration. So a bar instantaneous at t1. At t1, this will be given by, tell me, vt2 bar minus vt1 bar divided by t2 minus t1 such that
Limit delta t equals to 0.
limit
Tends to 0.
t2 minus t1 tends to 0. Are you with me?
Yes, sir.
This is how we define the instantaneous acceleration. Now we are going to start with rectilinear motions. Are you with me? So what is rectilinear motion, Krishna?
The rectilinear motion. Motion along a straight line.
Yes. So it is the motion along the straight line. Do you agree with me?
Yes, sir.
Now, if the motion is going to occur along a straight line, then the line along which motion occurs, that direction we are going to call it as x. Are you with me? So if the motion of the object occurs along this direction, I am going to simply call this direction as x. Are you with me?
Yes, sir.
I am not interested in y position because the object is moving along the line. So it is not going to move perpendicular to the line. So this position, this direction itself, I call it as x. Are you with me?
Yes, sir.
And then I choose a origin. So let me say I choose this origin. Now the position of a particle with reference to this origin, though it is a vector quantity, now will be easily given by plus or minus sign. Do you agree with me?
Yes, sir.
So if it is on positive side of x-axis, the position will have positive value. If it is on negative side of the x-axis, then it is going to have negative value. Do you agree with me?
Yes, sir.
हाँ. So therefore अब जरा position vector के terms में देखते हैं. देखो, if at time t equal to 0, the object was here. Are you with me?
Yes, sir.
So what is RT1 bar? RT1 bar is along the line and it is this one. Do you agree with me?
Yes, sir.
At time t equal to t2, let us say the particle has assumed this position. So what is r t2 bar? R t2 bar will be this line along the same direction. Do you agree with me?
Yes, sir.
And what will be the delta r bar? This will be delta r bar. Do you agree with me?
Yes, sir.
So as everything is happening along a line, therefore triangle law complete करने की नौबत आएगी नहीं. Are you with me?
Yes, sir.
So therefore this will be the change in position. Are you with me?
Yes, sir.
हाँ. चलो अब जरा एक चीज और रेक्टिलिनियर मोशन के लिए let us try and understand one more thing. What do we mean by positive and negative positions? So the vector nature of the position in rectilinear motions can be simply handled by positive and negative signs. Do you agree with me?
Yes, sir.
चलो अब जरा यहाँ पे देखो, this is the origin, this is the direction along which the motion has started. At t equal to t1, the object was occupying this position. Do you agree with me?
Yes, sir.
And at t equal to t2, the object was assuming this position. So the object is moving towards the origin. Are you with me?
Yes, sir.
So now tell me, how do I write delta? How do I write position of the object at time t equal to t2? So let me call this as x2 and let me call this as x1. Are you with me?
Yes, sir.
So what is the position x bar of an object at time t equal to t2? Tell me.
x1 bar minus x2 bar.
Its magnitude. No. Position. Plus x2. Do you agree with me?
Yes, sir.
So plus sign indicates the direction. Plus sign indicates the direction. And x2 indicates the magnitude. Are you with me?
Yes, sir.
What is the position of the object at t1?
x1
Plus
plus
x.
x.
Are you with me? So the position at t2 and position at t1 both are positive. Do you agree with me?
Yes, sir.
Now what is the change in position? Change in position we denote it by, let us say, delta x bar during t1 to t2. चलो बोलो तो क्या लिखना पड़ेगा? प्लस
x1 minus x2.
प्लस x2 minus plus x1. Do you agree with me? Do you agree with me?
Yes, sir.
And now will it be positive or negative? It is going to be negative because x2 is less than x1 and you are subtracting x1 from x2. So it is going to be negative. Do you agree with me?
Yes, sir.
And that is okay. Why? Because during time interval t1 to t2, the object has traveled in negative x direction. Are you with me? So change in position can be negative. That need not necessarily mean that the positions at t1 and t2 should be negative. Are you with me?
Yes, sir.
So absolute positions at t1 and t2 both are positive, but change in position is negative. You have to understand this. Are you with me?
Yes, sir.
So the sign of position itself at given instances of time and the sign of change in position during a given time need not be same. Happy?
Yes, sir.
I will give you one more example. Let us say this is the origin. The motion occurs along this line. Are you with me?
Yes, sir.
This is origin O. During time t equal to t1, the object has occupied this position. Are you with me?
Yes, sir.
This position at time t equal to t1. Are you with me?
Yes, sir.
And I am going to call this as, let us say, 4 units. Are you with me?
Yes, sir.
At time t equal to t2, the object has occupied this position where I am going to call this as 2 units. Happy?
Yes, sir.
Now tell me, what is the position of object at time t equal to t1?
4 units.
No, -4.
-4, sorry.
वेक्टर है ना, तो डायरेक्शन भी आना चाहिए. So -4 units. Do you agree with me?
Yes, sir.
So position at t equal to t1 is negative. What is the position at time t equal to t2?
-2.
Position, you can take it similar to position vector. So what is the time? What is the position? -2. And what is the change in position during time t equal to t1 to t2? Tell me that now.
Sir, 2 plus 2
-2
-2.
minus of -4. Agree with me? So how much is that?
+2.
+2. That means during time t equal to t1 plus t2, the object has moved in positive x direction by 2 units, and which is true. देखो यहाँ से यहाँ आया है. Do you agree with me?
Yes, sir.
So therefore, change in position is positive during time t1 to t2, but position itself at t1 and t2 is negative. Position vector has negative connotation. Are you with me?
Yes, sir.
So I hope you are very clear about the positive and negative sign of position and change in position. Are you with me?
Yes, sir.
The same discussion is valid for velocity as well. Now tell me, when do you say that the particle is possessing positive velocity?
Sir, when it is moving away from origin.
Moving?
Moving towards the positive x direction.
Yes. So now we are discussing all this in context of rectilinear motion. Are you with me? So therefore, if this is the origin and the object is moving in this direction, and if I call this direction as positive x, then I will say velocity to be positive only if it is directed along positive x-axis. Do you agree with me?
Yes, sir.
X-axis. So for velocity, it is fairly easy to understand when velocity is positive and when velocity is negative. Happy?
Yes, sir.
Now let us do that exercise for acceleration as well. Are you with me?
Yes, sir.
So for acceleration, so this is the x direction. Let us say this is the x direction. This is the origin. Are you with me?
Yes, sir.
Now I am going to take peculiar examples. Let us say the position at t1 t equal to t1 is this. Are you with me? And
Yes.
position at t equal to t2 is this. Happy?
Yes.
So this is x1 and this is x2. Are you with me?
Yes, sir.
Now tell me, what about the change in position? Is it positive or negative? So change in position, delta x bar, and let us take these values. Let me take x1 is equal to 2 and x2 is equal to 3. Are you with me?
Yes,
so what
sir.
is delta x bar during t equal to t1 to t equal to t2? Tell me.
Sir, x2 minus x1
minus 2
minus 2 1.
So even the positions were positive and change in position during time t1 to t2 is also positive. The object has moved in the positive x direction. Do you agree with me?
Yes, sir.
Okay. Now, second thing. Let me say the velocity, instantaneous velocity at t1 is 2 meter per second. Are you with me?
Yes, sir.
And instantaneous velocity at time t2 is 1 meter per second. Are you with me?
Yes, sir.
Okay, chalo. So now tell me, what is the average velocity during time interval t1 to t2? Tell me, average velocity.
Average velocity. So 2 minus 1.
So average velocity from t1 to t2. So क्या करना पड़ेगा? 3 minus 2 divided by, बोलो, t2 minus
T2
t1.
minus T1.
Do you agree with me?
Yes, sir.
T2 minus t. Is T2 minus T1 positive? Yes. So
Yes.
is numerator positive? Yes. Therefore, this average velocity is positive. Do you agree with me?
Yes, sir.
So it says that the average velocity is directed in positive x direction. Happy?
Yes, sir.
Now, when do you say that? What can you say about average acceleration during time t equal to t1 to time t equal to t2? Chalo. At t2, the velocity is 1 meter per second and plus because it is in positive x direction. Do you agree with me?
Yes, sir.
At t1, velocity is 2 meter per second and plus because it is in positive x direction. Do you agree with me?
Yes, sir.
So therefore, this will be t2 minus t1. Is t2 minus t1 positive?
Yes, sir.
And what about 1 minus 2? It is negative.
Negative.
Are you with me? So what
Yes.
is average acceleration?
Negative.
Are you with me? So not necessary that if the change in position is positive and average velocity is positive, the acceleration also should be positive. ऐसे जरूरी नहीं है. Are you with me?
Yes, sir.
So when do we say the acceleration is negative? One of the possibility is the object is slowing down in positive x direction. Do you agree with me?
Yes, sir.
Happy?
Yes, sir.
So when is acceleration positive? Object acceleration negative. Negative कब है? When it is slowing down in positive x direction, or when it is positive. Acceleration is positive. Acceleration is positive when object is speeding up. Speeding up in positive x direction. Do you agree with me? Happy?
Yes, sir.
अच्छा, अब जरा और एक चीज देखते हैं. Let us say this is the origin. Are you with me?
Yes, sir.
At time t equal to t1, this is the position, which I am going to call it as x1. Are you with me?
Yes, sir.
Is equal to 3 units, let us say. And at time t equal to t2, this is the position, which I am going to call it as x2, which is 1 unit. Are you with me?
Yes, sir.
So this is at time t equal to t2. This is at time t equal to t1. Now tell me what happens to the position. Position कैसा है बताओ? Change in position. Delta x bar during time t1 to t2 is what? Tell me.
3 minus.
No, 1
minus 3.
minus 3 divided by t2 minus t1. Do you agree with me?
No, sir. T2 minus T1 नहीं आएगा ना.
Why?
Change in position.
From t1 to t2, right? Change in position during t1 to t2. So t2 minus t1 ही तो आएगा. Are you with me?
हाँ.
So this is positive. Do you agree with me? But this is negative, which indicates that the change in position is negative. That means the object has traveled in negative x direction. Do you agree with me?
Yes, sir.
So positions are positive, but change in position from t1 to t2 is negative. The object has moved in negative x direction. Do you agree with me?
Yes, sir.
हाँ, तो अब जरा देखो, at time t1, let us say the object was having a velocity of 4 meter per second. Are you with me? And it was in negative x direction, because we have established that during time t1 to t2 the object is moving in negative x direction. Are you with me?
Yes, sir.
And at time t2 the object has a velocity of 6 meter per second.
Hmm.
Are you with me? Are you with me?
Yes, sir. Yes.
Now let us try and write down the change in velocity here. Sorry, let us try to write down the average velocity here. So how do I write average velocity over the time interval t1 to t2? कैसे लिखूं बताओ? We will finish this point and then we will stop for. Yeah, go ahead.
4 minus 6.
4
Minus 6
हाँ
divided by T2 minus T1.
no, not 4 minus 6. We are writing down the average velocity. So you
Okay,
have to
6
look at the
minus 4.
position. हाँ, so क्या करना पड़ेगा? 1 minus 3.
Okay. Divided by.
No. I think we made a mistake here. This has to be only
1
1
minus 3.
Yes. And now when I write the average velocity, now it becomes 1 minus 3 upon t2 minus
T2
t1.
minus T1.
And still it is negative. Do you agree with me?
Yes, sir.
So average velocity, as it is being directed from directed in negative direction, it is negative. Happy?
Yes, sir.
Now let us write down now average acceleration from t1 to t2. क्या लिखूं?
Sir,
minus 6
minus 6
minus of minus 4
minus 4
divided by t2 minus t1. Do you agree with me?
Yes, sir.
And it is negative.
Yes, sir.
So when is the acceleration negative? The object is speeding up but in negative x direction. Are you with me?
Yes, sir.
Object is speeding up in negative x direction, then also the acceleration is negative. Object is speeding up, mind you, but as it is speeding up in negative x direction, therefore the acceleration turns out to be negative. Are you with me?
Yes, sir.
So when is acceleration positive?
So when the object is speeding up in positive x direction, and yes,
and second is object is
slowing down in
slowing down.
negative x direction.
So object is slowing down in negative x direction, then also acceleration is positive. Are you with me?
Yes, sir.
So acceleration positive है कि नहीं ये देखने के लिए थोड़ा tricky है. So there are two conditions when acceleration is positive. Either the object is speeding up in positive x direction or it is slowing down in negative x direction. Are you with me?
Yes, sir.
Then we call that the acceleration is negative. Now some books use the word deceleration. Are you with me?
Yes.
I won't use the word deceleration. Deceleration is deceptive word. Don't use it. We will simply say whether the acceleration is positive or negative. Are you with me?
Yes, sir.
Because if you start using deceleration as a word, then it confuses you. The object is speeding up. Still we call it as deceleration. Why? Because it is speeding up in negative direction. Are you with me?
Yes, sir.
Therefore, we should use only positive acceleration or negative acceleration. Try avoiding using word deceleration. Are you with me?
Yes.
Okay. So we have now understood what is position, change in position, velocity, change in velocity, acceleration, change in acceleration. When is average and instantaneous values of velocity and acceleration? When is position positive? When is change in position positive? When is velocity positive? When is average velocity positive? When is acceleration positive? When is average acceleration positive? ये सारी चीजें हमने आज सीखी है. Are you with me?
Yes, sir.
Pertaining to rectilinear motion. We are now going to use these things while solving the problem in tomorrow's class. Okay?
Yes, sir.
Okay, so let us stop here. Write down your name and roll number in the chat box and then you can leave the meeting. If anyone has any doubts, you can ask me now.